Hi folks, welcome to the Breaking. My name's Henry, and today we're going to take care of some quality of life things with the Forth ROM. Moving forward, I want to get into the compile mode, but before I get to the compile mode, I want to have signed arithmetic. That's something that is in the Forth standard. The arithmetic is supposed to be signed. The other thing is there are a couple of bugs that I want to squash. I want to fix that end of line bug where if we get the cursor right to the end of the line and we finish something out, it doesn't realize that it needs to give an extra line's worth of space for the output. The other one is making base currently is a word that does things, and according to the standard, base is not a word that does things, so we want to fix that. And in fixing that, I also want to make sure we have prefixes available for numeric data types. So we got a little bit of a smorgasbord this time around as we go through and fix some problems and build some quality of life and get ready for going into compile mode on the Forth ROM right here today at the break key. So the problem is that when the cursor hits the end of the line, if that's where it's sitting right when everything finishes, it doesn't advance the line. Let's see if we can't duplicate that. Now, if I hit enter here, oh, that went awry. Oh, I bet it overflowed. Let's try that again. Oh, that's interesting. All right, folks, I am thoroughly confused here. I've gone through all sorts of testing on this, and I've got this condition where apparently I put 4 things onto the user stack, run 3 additions, and try to run effectively a multiplication. This is going through the process of figuring out what the digits are. And all I'm doing is calculating powers of the radix, in this case powers of 10. I've tried it with powers of 16 and it's doing the same thing. I'm coming to the final multiplication in the third, I think it's the third digit, I'm coming to the final multiplication, which is bringing me to the second power, 0th first second power of the digit. And if I hit this and just do that multiplication, I have no idea what's going on here. My program counter's correct, B2D5, everything's going fine. Things look normal. And I hit that, I go to that next one, excuse me, and it goes and works this time. What in the world happened there? All right, so let's... Whoa! I don't understand what the heck just happened there. I need to back up and do a frame grab and look at this. Hang on. All right, after some time off camera, I think I may have figured out what's going on with that wonkiness. This is what I think my biggest problem is this and CC right here, E0. Because I did a little bit of slow motion to see what was going on. And it looked like I had interrupts unmasked. At this point, fast interrupts and interrupts are masked, as should be the case. Now, if I single step through this, now here's the trick, and CCE0. What I should see here is the interrupt mask go away, and it does. When we return BNE A33B, or well, no, we're not doing it. Load X20C, load A20, sorry, and there's an AND-CC F0, which should come up with the interrupts still unmasked. We do an RTS from there. We go back to A2C2, which is, let's see, maybe not. Where am I at right here? I'm at A2BE. Actually, if I F5 from here, it'll show me. me F5, and interrupts are remasked. So somewhere along the line, it remasks the interrupts, and that's going to be done with an OR CC somewhere. So let's see where that OR CC is. OR CC pound 50, that's at A0BB, which is there, and there's another one there, OR CC 01, set the carry flag. This is happening during the main loop. And here, OR CC 01, exit with carry set. And then it's coming back to the top somewhere and resetting. That's only happening at the top. Where am I seeing this happen somewhere else? Do I have an EOR CC or do I have a... Oh, that's what's going on there. Because I knew I was going to be clobbering CC. Now you make sense. Now I understand what happened there. Okay. So the error condition simply is, I have a sneaking that what I've done here is I've put some legacy code in, or I've left some legacy code in, and that legacy, and the legacy code was working mostly, but then failed to, but then as soon as I wound up doing a process that spans a vertical refresh into frame, it breaks, and this is what's been happening. So in the dictionary, I should have, so this, that should be able to go away. Because at that point, that's no longer necessary. Yeah, because those are the only places those are found. I've only got 2 locations. So that should be no longer necessary. Let's find the next one. And that should be no longer necessary. So that should fix it. And that should have no problems whatsoever. We should have, wow, that was, okay. And all right, and there's what I expected with this. That's the end of line bug that I was originally looking at. Before doing so, exposed the fact that I jacked up my interrupt masking. The end of line bug is occurring because I'm putting out the OK message but not updating the location of the cursor. And I did that so I could put out the OK message and not have to worry about doing it for every single one. But the trick is, once I get to the enter, that's where I need to, at the end of the processing of the enter is where I need to actually put the OK message, I do believe. And we should be good. I think I need to allow Y to be clobbered here. So we'll just push SX because when we pull Y back, Y's got the print cursor location. Pulse X. All right, that's doing exactly what I expected to do and what it needs to do. All right, so that problem's fixed. We're done with the end of line bug. So according to the standard, the word base does not set the base. The word base puts on the stack the address of a cell containing the current radix. So with that, without massive modification of how the code works and making it way too big, the easiest, I can't realistically, where'd it go? I can't realistically leave that as a single byte value. So I will need to increase that to a dual byte value. Everything else still works with radix where it is. Go over to the dictionary, and I need to add the word, I need to modify what base actually does. Now I need to do range checking when I'm doing any type of conversions. So dot does a conversion, and where else am I looking at radix? In this particular case, I'm not even going to issue a warning. Having a radix of less than 2 and having a radix of greater than 36 is an error condition, but it's an error condition that I can't get out of until I implement the, let's see, these bad boys, the prefixes here. So that is actually the next thing that I'm going to want to do. I think that fixed it. Good. Nice. And that's where I didn't put it, so I need to fix that in the dot. Lovely. That's all working. So for our next bit, we're changing over from unsigned to signed arithmetic. We do leave some unsigned things in. So right now, dot is unsigned. There are a few other things that are unsigned. So I'm not really sure if any of the mathematical operations at all really need to be changed out, because we are dealing with two's complement here. We'll check multiplication and division. I know addition and subtraction shouldn't be an issue. So for the time being, all I want to do is add in the capability to print and to input negative values. So for doing two's complement, this is actually quite easy to do, because to negate a number, you simply not inc, or not an increment it. We have two different facilities in the 6809 to take care of that. Let's see if I've got those in here. I realize that like div and mul, they're going to overflow on me because, well, they're going to try and overflow on me because I'm going to be dealing with negative numbers. So I'm going to have to rewrite those. I'm going to have to rewrite mul, and I'm going to have to rewrite div. So we'll work with that later. Right now, let's see what we can do about just getting ourselves printing negative numbers. I see what I did wrong. I see exactly what I did wrong. Okay. That was common error. Common error. Forgot to put the things on there. There we go. That should fix it. Now let's run it. Oh, okay. I see what happened there. It did. Right. And I'll bet you nickel it doesn't have a COMD, does it? Nope, it's only got the COM A and COM B. So let's see what neg does. We don't want to neg that. What we want to do, because we're working with 16-bit values and not 8-bit values, we want to do a COM, and then we want to do an add 1. So that's going to change out how that works. that gives me, oh. Yep, okay, so that's doing everything correctly. So now I want to be able to enter negative numbers directly. And that's going to be a little bit of fun because I'm going to have to refactor some of this. I looked into what gforth does, and gforth allows me to put the prefix either before or after the negative sign. It doesn't care which. So I want the prefixes and I want the sign, and I can't guarantee that I'm going to hit one before the other. So the only trigger I have is, have I seen a digit yet? Lovely. Perfect. That is exactly what I wanted to see. Now, there's another problem. I don't believe I've set the have I seen a digit marker. So that's going to come and bite me in the butt later. And that's what I figured. All right. So it's coming back around to that. Lovely. All right, that seems to be perfectly working. And if I do a oh, that was my problem. I have to do it now. I have to And that broke that. I still don't want it to process a negative sign if it sees it after having received a 0. So even though that's there, the value is 0. I need another flag. I need another flag. That's all there is to it. I need another flag. That kind of sucks. Do I have an empty flags register somewhere that I can play with? Let's look at our memory. Let's set up our num flags. Okay, we'll do this. Why did that happen? That shouldn't have changed my display base. Oh, LBSR. Brr. It's a subroutine. Of course it's not going to do right. Okay. Let's try this again. Lovely. All right, so that's working. That was a royal pain in the posterior. Oh my goodness, I can't believe how difficult that was. And since it was annoying me, I will put in some quality of life items here. Quality of life done. Now on from quality of life to looking at math. So what we've been doing is an unsigned multiplication where we have an explicit overflow if we have too big of a number. Well, okay, I checked it out. Forth doesn't do overflows with arithmetic. If you have too big of a number that will exceed the cell width when you multiply, all it does is it does the full multiplication, but then it truncates, so you lose the most significant n bits, however big the bit width is. In our case, our bit width is 16. So if you multiply two numbers together and the resultant is greater than 16 bits, you wind up with a 16-bit number. It's just the upper 16 bits that would have been the upper 16 bits are gone, and the lower 16 bits are what are kept. So there is a word in, let's see. So this one looks at mul. I'm going to have you look at M star, and is going to be our actual multiplication. What we will do is we will take two 16-bit wide numbers. This is going to be two cells, multiply them together, and bring them into a double precision number. This is what this will do. These are signed numbers, so we will be sign extending our resultant. D is the signed product of n1 times n2, and you'll notice that this only does signed numbers. So if we take our M star, and that looks correct. And if I do a 10, if I do a FF, M star. At this point, I haven't done anything with signedness, so I'm still needing to look at that. So let me look at 7F, M star, ... and I come up with a 0, 3F01. That's interesting. I would think it would be more than that. So what if I do a, oh, right, 7FFF, 7FFF, M star, ... 3FFF1. That looks more like what I was expecting. So what I can't remember is whether or not I tested mul at this point. So let's check that. And when I dot that, let me do a dupe dot u dot. Oh, something went terribly awry. Oh, well, that would cause a problem now, wouldn't it? I need that to be over here. And now dot isn't showing me the negative number. What happened there? Negative 7 FFF 8001, which is precisely what I wanted to see. However, if I take that 7 FFF, multiply it by the -1, it doesn't negate and it doesn't sign extend into 64 bits. So what happens if I sign extend this, or 32 bits, I'm sorry, what happens if I sign extend this? So signed multiplication is working. Let's see. The entire thing of checking for sign extension, that's something that I will want to break this out. Because I will be using this particular routine for division as well. It makes sense for it to be in its own little place. With multiplication done-ish, now we want to look at division. I've still got to break this out into its own routine. We'll figure that out here in a bit. Division, yes, we've already done it, but we've done it unsigned. In the case of the fourth standard, you'll see that, well, this result will be the same as one of these two phrases. This is a floored division, and this is a symmetric division. From the research I've done, most of the implementations across processors that have hardware division is symmetric division, which has the interesting side effect of leaving us with a negative remainder. Some people don't like that. It's going to be the easiest to implement overall. But let's look at what's happening here. The first thing it does is this 2R, which is simply we move the top of the stack to the return stack. Easy enough. We get it out of the way. And then the next thing we do is the S to D. S to D converts a single precision number or a single cell number to a double cell number. Easy enough. And then R from. Get that back over there. All we're doing is effectively changing our dividend to a double cell number so that we can then work on it using symmetric division, leaving us with the quotient and the remainder. Divide D1 by N1, giving the symmetric quotient N3, which will be at the top of the stack, and the remainder N2, which will be at the next on stack. Thus, when we look at this, the swap drop. So I have a few words that we're going to write. So if I have 1 s to d u dot 0 1 x negative 1 s to d u dot. Lovely. That's exactly what I wanted to see. Now, with all of that out of the way, we can finally get to actually doing the division. that's where my problem was. Okay. I did a negative 4 comma u instead of a 4 comma u. Got it, because I haven't changed those over yet. Blah, blah, blah. All right, good. And that's all correct. Beautiful. That's taking care of it exactly the way it should. I'm happy. The next test is our overflow condition. Good. That's the overflow condition that I wanted to see. That's exactly the overflow condition that I wanted to see. It did that perfectly. Division works. At least now. Now the next trick is getting the division to do what division does with the div word, and I think x 6018 divide dot comes up with 400. Nice. And it comes up with 0. X 6000, no, 7000, 18 divide dot comes up with 4AA. And just to make sure, lovely. 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 All right. This is all working, and it's working well. Well, that was more of a marathon than I expected it to be, but hey, I think it's worth it. So it was completely unexpected that I had some kind of vertical refresh interrupt problem going on. I'm glad that was located and quashed. The end of line bug is now fixed. Base now does what it's supposed to do according to the standard. And we have signed multiplication, division, addition, and subtraction, as well as display of those things. Quality of life enhanced. Lovely. Now, for our next trick in the Forth ROM, we will be going into the compile mode. I know I don't have all the immediate mode words ready in there yet. As we run across them, we'll add them. And if there's any small things between now and then that I might need to fix in order to make it work, just let's fix them. So I hope you've had fun just watching me kind of throw my head against the wall dealing with this, because believe it or not, it is fun for me. I do enjoy doing these kinds of things. And next time we can expect a return to the USB keyboard to Coco adapter. So be sure to like, share, and subscribe. Well, the last part actually gets you the notifications. The first two help build the channel, which is something that I really do appreciate. So thank you so much for tuning in. Really appreciate you being here. Come in and join us next time right here on The Break Key.